Hello, we're going to get right into it for this lesson. So dividing polynomials. Our learning goals, we're going to use a variety of strategies to determine the quotient when dividing polynomials. And so you know where we're going with this eventually down the line. We're looking to get to factored form and factoring things larger than a degree of 2, which is a quadratic, which you would have done in grade 10 and grade 11. Before we move forward, though, we're going to have to go back in time. And we're going to recall long division from elementary school. If you did long division in elementary school, it looks like this. Your divisor is 8. Underneath that division sign is the dividend. You have a quotient, which is on top, and a remainder. And the divisor times the quotient plus the remainder gives you the dividend. That's not super important information, just getting you back into the terminology that's going to be used. So maybe you remember how to do this, maybe you don't. That's why we're going to review it. And you don't even have to copy this part down. You can just pay attention. But this is going to help us come up with the process. So we're going to do something relatively simple to get the process to move on to something significantly harder. At least look significantly harder. So 620 divided by 8, and we're not going to use our calculator. We're going to do this manually by hand. So write the 8 out front, then our division sign, 620. Where do we go from there? Well, we have basically 3 steps that we always want to do. We want to divide, multiply, then subtract, and repeat the process. So let's start by dividing. Does 8 go into 6? No. So then you go into 62. Does 8 go into 62? Yes. How many times? 7. So there's our divide step. Now we multiply. And what do you multiply? You multiply 8 times 7 to get 56. Then you subtract. 62 minus 56 is 6. And the key step here is bring down the 0 and you repeat. Does 8 go into 6? No. Does 8 go into 60? Yes. How many times? 7. 7 times 8, 56. Subtract 4. Once there's nothing else to bring down, you know you're done. And that's your remainder. And if you had to write a division step, even though it's kind of overkill for this, we will be doing it for polynomials. Therefore, 620 equals 8 times 77 plus 4. And you can always double check that, right? Type in your calculator, 8 times 77 plus 4, you'll get 620. Same process, let's try it for 107 divided by 4. So 4, 107. Does 4 go into 1? No. 10? Yes. Goes in twice. 4 times 2 is 8. Subtract is 2. Bring down the 7. Does 4 go into 27? Yes. 6 times. Multiply. 6 times 4 is 24. Subtract. We get a remainder of 3. Nothing else to bring down. Therefore, we know we are done dividing. Therefore, 107 equals 4 times 26 plus 3. I shouldn't say times 3. So hopefully that's bringing back happy memories of dividing in elementary school using long division. We are definitely going to build off of this process. Now we're going to fast forward, still go back in time, but fast forward from elementary school, maybe as recently as last year, even last semester. Recalling grade 11, and in grade 11, everyone's favorite unit on rationals and radicals, you do something like that and you're asked to simplify. Really though, what are you doing? You see that fraction line, that really just means divide. And how you were taught to do this is factor, which the top factor is 2x plus 6 and x plus 1. And when you have things that are the same on top and bottom, you can cancel out, and you're left, oops, don't cancel out the plus 6. X plus 1 cancels out with the other x plus 1, and you're left with x plus 6. And yes, you had the state restrictions. I don't care about that for this. Really, though, what you were doing is you were dividing. And if we were to follow up our therefore statement, therefore, x squared plus 7x plus 6 equals x plus 1, which is what you divided by, and what you were left over with, x plus 6. Now in grade 11, everything always factored nicely and you were able to at least do some canceling for almost every question. Obviously, not every question is going to factor nicely and work out nicely. And that's where we're going to come in today with dividing polynomials using long division. So when the equation is not factorable, or the denominator is not an even factor of the numerator, like it always was in grade 11, long division is needed. So we're going to start with this example. Obviously, you can't factor the top, so we're going to just divide. Now you're going to have to bear with me because the first time you see this, it's going to look intimidating. Maybe even the second time you see it, it's going to look intimidating. The more you practice, though, the more it's not bad. And then I'm going to show you a different way you can do some of these questions, which often becomes the preferred way. So we're going to follow our process we did going back to elementary school. So I'm dividing by x plus 1. So I'm going to write here x plus 1, my divide symbol, and then x squared plus 7x minus 3. And remember these steps. So we're going to divide, multiply, subtract, repeat. So the first thing you're going to do, how many times does x go into x squared? And you don't have to write this work for every single question. I'm just going to do it for the first time, or first couple times. So you're going to do divide. X squared divided by x, which equals x. That's going to always go over the degree. So the degree of that always goes over whichever column has the x in it, which is this. So x. Now you're going to multiply. What are you going to multiply? You're going to multiply x times x plus 1. So x times x plus 1. So there's a step, there's a step. X times x is x squared, and x times 1 is x. If you've done your work correctly, you should always have x squareds over x squareds and x's over x's. Now we're going to subtract. X squared minus x squared is 0x squared. Now I'm going to write the 0 for this first time, but you don't have to from now on. And that's always the goal of this, is to get those to cancel out, to get to 0. And then 7x minus x gives you 6x. Now we need to bring down this number, minus 3, and we repeat that process all over again. So we're going to divide. So this was kind of like the first time we did it. This will be the second time we do it. So now we're going to go back up, and 6x divided by x, right? This divided by this, and that equals 6. So plus 6. Now you multiply. So 6 times x plus 1, which gives you 6x plus 6 then we subtract 6x minus 6x, they're gone, 0x, and negative 3 minus 6 is negative 9 remainder. And there is nothing else to bring down, so you know you are done. So again, I know that's a lot the first time and it looks confusing once you kind of get the hang of it. And you might even want to retry those elementary school ones to kind of mimic this process. So we're ready for our therefore statement. Therefore, x squared plus 7x minus 3 equals x plus 1 times x plus 6 minus 9. And you could always double check that. So you could FOIL x plus 1 and x plus 6, and then subtract 9, and you should get the quotient back. Or the dividend, I should say. Now I'm going to add a couple things to this. Organizational things. So your columns should always line up perfectly, meaning that right there should only be x squared terms. This column should always be x terms. This column should always be constant terms, or just numbers. If you have something in a column that doesn't belong there, it's going to mess up your division. So just make sure you kind of keep those organized. And we're going to be doing stuff where we divide cubics and we divide quartics, like degree of 3, degree of 4, same thing. All the cube terms under each other, all the squares, all the x's, all the constants, and so on. And just so you know, when you get to the homework question, sometimes they ask you for the division statement. That right there that we've been doing with the therefore statement is your division statement. All right, let's tackle another question. So this one's kicked it up a degree. So we're now doing degree of 3, same process. So write out your 2x plus 1, division symbol, 4x cubed plus 6x squared plus 12x plus 5. One thing now that I think about it that I want to remind you as well, when you do these, they should be written in descending order of x. So if I give you, or the textbook gives you a question that has those mixed up, don't just write them there because it's going to mess up your division. Make sure you write it from highest exponent to lowest exponent. So again, I'm going to write this on the side just to kind of show you while I explain, but you don't have to do this when you are doing your own solutions. So remember, our steps are divide, so divide, multiply, subtract, repeat. Divide, multiply, subtract, repeat. Divide, multiply, subtract, repeat. So the first thing you're going to start off with, 4x cubed divided by this. So 4x cubed over 2x. What does that equal? That equals 2x squared. And since that's a square term, that has to go in the squared column. So right here, so 2x squared. Now you multiply. So that number, 2x squared times what you're dividing by, 2x plus 1. So that gives you 4x cubed plus 2x squared. Now we subtract. If we've done it correctly, we should get 0, that first thing, which we do. We get 4x cubed minus 4x cubed. X cubes are gone, 0. And you don't have to, last time I wrote the 0 there, you don't have to write the 0, it's just visual clutter. 6x squared minus 2x squared gives us 4x squared. Bring this down, and you're basically rinse, wash, repeat. So divide. What do we divide? 4x squared divided by 2x, which leaves us with 2x, and that goes above the x column. Now we multiply. What do you multiply? What you just got, 2x times 2x plus 1, which gives us 4x squared plus 2x. Subtract 4x squared minus 4x squared. It's gone as it should be. 12 minus 2 is 10. Bring down the 5. Now we're ready to repeat the process again. What are we dividing? 10x by 2x, which just gives you 5. Multiply. What are we multiplying? 5 times 2x plus 1, which gives us 10x plus 5. Subtract. This worked out pretty nice. 10x minus 10x is 0. 5 minus 5 is 0. That means it's 0 remainder. That means 2x plus 1 actually divides evenly into that cubic. Don't forget your therefore statement. Therefore, 4x cubed plus 6x squared plus 12x plus 5 equals 2x plus 1 times 2x squared plus 2x plus 5. So hopefully it makes a little bit more sense the second time. Let's do it again. And first thing, check to make sure it's written in descending order of x, highest exponent to lowest, which it is. But there's one thing you always have to look for. So if I'm looking at this, I got a 4. So I got a 4, I got a 3, I got a 2, and then it jumps to just the constant term, the number. So you're missing the x term. Whenever that is the case, if you're missing any term, if we're missing the square term, the cube term, whatever, you have to put a 0 placeholder in. Always place a 0 placeholder for any missing terms. Otherwise, your division statement's going to be all messed up. And you'll know that you've forgotten because we're going to get to a point where the degree in each column doesn't match up. So you'll be doing like an x cubed minus an x squared, which that should never be the case. All right, we're ready to tackle this. X squared minus 3x plus 1 divides into 3x4 minus 2x cubed plus 4x squared. Put your 0 placeholder in, so plus 0x plus 4. Now I'm going to stop writing those steps on the right hand side that I was, the divide, multiply, subtract, repeat. If you need to, you can go ahead and do that if it helps keep you organized and helps you remember the steps. I'm obviously still going to talk about them verbally. Step number 1, divide. This divided by this. 3x to the 4 divided by x squared will give you 3x squared. That's going to go above the squared column. Now we multiply. Multiply this that you just wrote by x squared minus 3x plus 1. So that's going to give you 3x to the 4 minus 9x cubed and plus 3x squared. Subtract. Those cancel. The first term's perfect. Now, another common area for mistakes. Do not forget you are subtracting. So this is -2 minus -9, which don't forget 2 negatives make a positive. So really this is -2 plus 9, which is 7x cubed. 4x squared minus 3x squared is just 1x squared bring down the 0x, and repeat. Divide this by this, gives you 7x. Now multiply 7x cubed minus 21x squared plus 7x. Subtract that minus that, they're gone, perfect. X minus negative 21 is really x plus 21, so that's 22x squared, 0 minus 7, negative 7x, bring down the 4. Repeat. This divided by this is just 22. Multiply 22x squared minus 66x plus 22. Subtract. Those first terms cancel perfectly. Negative 7 minus negative 66 is really plus 66, so that's 59x. 4 minus 22, negative 18. Nothing else to bring down. That's our remainder. And this is a good example because it shows you about the 0 placeholder, but also that your remainder doesn't have to be just numbers. It could also have variables in it. Could be an expression, could be a polynomial, which in this case it's a binomial, 2 terms. So therefore, 3x to the 4 minus 2x cubed plus 4x squared plus 4 equals x squared minus 3x plus 1 times 3x squared plus 7x plus 22 plus 59x minus 18. Phew. All right. So now that I hope everyone's got that down pat, I'm going to show you a different way that's probably going to become your preferred way. And this only works on some of them. So this is synthetic division. This is a short form of long division that can only be done when the divisor is x minus a. So you can only do synthetic. I can't stress this enough. You can only do synthetic if it's like x minus 3, x plus 3. If for our last example we had an x squared minus 3x plus 1, can't do synthetic. The example before that we had 2x plus 1, that's not x minus a, can't do synthetic. And I shouldn't say that you can't for that one, 2x plus 1, but I'm not going to show you how. It's more complicated, and I'm going to expect that you, for your test, only do synthetic division for these. So x minus a. So if you see something like the last 2 examples we just did, you cannot do, or my expectation is you're not going to do synthetic division for those on your test because I haven't actually shown you, and I'm not going to show you, only for this. All right, so this is what this looks like. You're kind of going to draw an upside down divide symbol. So you're going to draw something that looks like that. And, oh, I guess I should pop up the question for you. I'm going to erase that. Got ahead of myself. Okay, so there's our question. So we're going to draw that upside down kind of division symbol. And what you do across the top is you write all of the coefficients. And again, you're still checking for if it's in descending order of x and if you have to put a 0 placeholder, which we don't. So the first thing you're going to do is write all the coefficients across the top. So 3, negative 5, negative 7, negative 1. We're going to make a note here. So this was step 1. Write the coefficients. Then out front, you're going to write the a value. which is 3. Now, if you're thinking, whoa, I think it's negative 3, just remember that when it's in factored form, it's always x minus. Another way to think about it, you see x minus 3. What's the opposite of minus 3 plus 3? All right, so here's where we go from here. So this was step number 2. Step number 3, bring that 3 down. And I'm going to show you some arrows to kind of guide you what to do. You don't have to do these arrows from now on. So what you do is you do this times this. 3 times 3 is 9. And then you add. So we're going to add. Negative 5 plus 9 is 4. Then you kind of repeat that process. This times this. 3 times 4 is 12. We are adding. Negative 7 plus 12 is 5. Multiply that by that. So 3 times 5 is 15. We are adding. Negative 1 plus 15 is 14. So we're going to make a note here. Now, if you want to keep writing those addition signs in there, you can. I'm just going to write always adding, don't forget. Now, how does that give us our answer? Well, this last number here, so forever and always, that is your remainder. And then as you go this way, you're going to increase the power on x, or the degree on x. So 14 is our remainder. It was plus. 5, right? There's no x. Increase the power of x by 1, so it goes to 4x. Increase the power of x by 1, 3x squared. So there is our division done. And if you don't believe me, then try this long division and you should get the exact same answer. So therefore, 3x cubed minus 5x squared minus 7x minus 1 equals 3x squared plus 4x plus 5 times x minus 3 plus 14. Once you get to practice this, I guarantee this is going to be your preferred method for division of polynomials that are being divided by something like x minus a. So I'm going to give you one to try, but I'm going to start it off for you. So step number 1, draw that like upside down division or that big elongated L. Write your coefficients. 4, negative 5, 3, negative 7. Double check again for descending order of x and 0 placeholders, which we don't have in this case. Write your a value, which is 2. Remember, it's x minus 2, and you can think of it like opposites if you want. Bring down the 4. Multiply 2 times 4. Actually, we'll just do it together because it's the second time you've done it. 2. If you want to challenge yourself, then by all means pause it and come back. Now you multiply. 2 times 4 is 8. We are forever adding. Negative 5 plus 8 is 3. Multiply 2 times 3 is 6. We're forever adding. 9. 2 times 9, 18. We are forever adding. Negative 7 plus 18 is 11. How does that give us an answer? 11 is our remainder, plus 9, plus 3x, 4x squared. Therefore, 4x cubed minus 5x squared plus 3x minus 7 equals 4x squared plus 3x plus 9 times x minus 2 plus 11. So since you didn't really have to do this one on your own, or maybe you did, maybe go like cover up this solution, retry on your own to make sure you can do it without looking. So that's it for this lesson. There's your work. Again, double check D2L to make sure I didn't change the questions. If you're thinking in your head, like once you do the practice and you're like, whoa, I actually like synthetic, that's perfectly fine. Make sure you still know how to do long division because like I said, synthetic only works on specific questions. And on your test, I'm not necessarily going to force you to do synthetic or long division, but if it's a question that you are not able to do synthetic on, your obvious choice, the only choice you have is long division. So make sure you still know how to do long division, especially for questions that aren't of the format x minus a.